Oh my God, this is the second expedition for the day. And look at this, oh my God, it's so gorgeous.
Okay.
Look, look, look. Wow. Oh my God, awesome.
Well, jump.
Oh my God, we're starting.
Check the pump.
Or maybe not.
All right, smile everybody.
I thought you said 5 and then you only come to 3.
Oh, he's pushing the ice away. Oh, that's nice.
Oh my God, Bridget.
And they were reprinting the car. And Pablo thought that was in my.
Do you have enough video for that?
So that is what he was telling
You
me.
came
There
prepared.
is one less in your Zodiac. No, I was
Too
counting.
much to see here.
Oh my God, yeah. Oh, look at this.
It's amazing.
No. 10 is one thing. 25 is. I have some stories to tell. But yes, wait.
Don't forget them.
25.
Oh my God, look at this, look at this, look at this.
Alright, so do you know where we are?
Glacier.
On the Zodiac, that's not wrong. Also in the Arctic, also not wrong.
Glacier.
Yeah, it is. It's a lovely place.
Whoa, view that. Wow.
Look at this. Look where we're going.
Flip over.
You know, if anything happens, we can sleep here.
Oh, no. You might want to, I don't.
That might happen a few times.
Actually, I wouldn't mind. Bring me some blankets and I'm good.
Yeah, there's quite big guys around here, so. Yeah,
Come on, give us a tow.
Whoa.
We beat the ice.
right now we're trying to spot a seal. We saw a seal over where the other zodiacs are. So that's where we're heading.
Good. What's your name?
Louise.
Louise. Nice to meet you, Louise.
I'm going to ask you for your names, and I'll try, but I'll probably have to ask you a few times. What?
Your name?
Kehal. Okay.
I'm Bridget.
Bridget?
Ryan.
Ryan?
Bonnie.
Bonnie?
Nancy.
Nancy?
Carol.
Say again?
Carol.
Carol? Kingston? Jamie? Randy.
Okay, now, go ahead.
Okay, let's try again.
Wow.
You didn't ask this guy.
It is.
Who is this guy here?
No one.
You know that what Ulysses said in on the Odyssey? He's no one. What's this? Yeah. Look at this. Look at this.
Yeah, it's okay.
Crunch.
But you don't really need it up here, so I don't get to practice that.
And that's our home.
Yeah, that's the compressed ice. Do you guys know how glaciers form?
You can tell us.
Okay, so in general, glaciers are just compressed ice. So it starts off with ice, and then over the years, the ice stays. And as soon as you guys are in feet, right? So this might be a bit difficult. If you have 3 feet of glacier ice in the end, you have had to have 300 feet of ice on top of that, or snow, to make the glacier ice. So yeah, all these glaciers are at least hundreds of years old. We don't really know because we haven't been doing too many studies on them up here, but yeah, they're quite old, and it needs quite a bit of pressure to make the ice underneath.
So when the glacier is like blue or like a green or whatever, does that mean that it's older? I know Seba was saying it had more compression.
Yeah,
but
exactly.
it also means that it's older, right?
Usually that means that it's older as well, yeah.
Yeah.
It's very dense. Yeah, we can take out a piece of ice and then I can show you.
I think he likes doing that.
He does.
He likes to freeze his little fingers off.
The ice is bigger than you think.
Oh my God, good girl. Look at that. Oh, look at that. Oh my God. Is that considered the
there's nothing
Arctic
small.
plunge?
They're really big.
It's not plunge, but hey,
Oh, that's a nice
she beat you. Someone beat you.
Yeah, there's
Seba.
some bubbles in it.
Wow.
bubbly.
That's why.
Pass it along. It's nice and cool.
The one that we
This
had.
one is nice, but it's not
Oh,
what I'm
oh,
looking
that's
for.
even prettier.
What are you looking for?
Oh, look at
It's like a
that.
curling
You
stone.
can.
Nice.
Wow. Yeah, it does. Actually, it looks like a beautiful water-free crystal.
Water-free crystal, huh?
Yeah, look at that. It looks like gorgeous. If he can sell it within like 5 minutes, you can make money. And then it's going to be gone.
You have to run fast.
Yeah. That was fun though.
You see here, there are 2 degrees of compactation in here, and where are the air bubbles? When the snow compresses, it's losing the air bubbles inside. The snow is having a lot of snow, air. Sorry, all the snow is very airy. So the compression begins when you are having 60 feet of snow making pressure. The one in the bottom begins to compress and lose the air inside. So after a few years, that could be 3, 4, 5, 10, 20, depends of the amount of snow every year that is falling in the place. After that compression, you are having glacial ice. Once that you are having glacial ice, the ice is compressing because of the pressure. So it's not the same, the ice at the top, that all the ice that is at the bottom of the glacier receiving all the weight of maybe many feet of ice. So when the ice is really compressed, it's losing more and more bubbles. So the bubbles in the distance make the ice whiter. So the bluer color is in this part that look like a glass. So if you can see the ice in this way, or you see it in this way, or in this way look different. That makes that when the icebergs are turning, looks in different blue color. The blue color depends on the reflection of the light. The light passes through the ice in bigger pieces, like the glass, and reflects only the blue color. So that is why we can see it blue. But we can see the bluer color according to the ice compression degree. So not necessarily always is the oldest ice. Always the oldest ice is bluer. But sometimes there is newer ice that look blue, and it's because it's more compressed. Where the ice is more compressed? On the sides of the glacier, where it receives all the pressure of the glaciers on the side, in the bottom. And there is something that is very complicated to understand, but the ice is melting only because of 2 reasons. Because of the heat, so if it's warm, or because of the pressure. If I'm making pressure here, I'm going to leave a line of water behind. So when you are having huge glaciers, because of the pressure, the ice melts inside and refreezes immediately. And when it's melt, lose the air bubbles inside, and when refreezes, is with less bubbles inside. So that is why you can see lines that are bluer there on the glacier.
Oh
That
yeah,
is
you can
because
see
that
lines.
were
Look at that.
melt under a huge pressure. It's a very complex subject, but it's very interesting. We can see bluer color today because it's cloudy. When it's really sunny, it's beautiful, but all the ice look whiter.
Oh really?
So usually the pictures are overexposed. So only you need a sunny day if it's going to be completely clear and you have the blue sky that is going to be reflecting the water. If not, it's better to have a light day today. For me, for a picture of a glacier, it's much better that dark cloud behind than the blue sky, because the contrast is the best.
Yeah.
So usually the most of the pictures of glaciers in National Geographic magazines are in cloudy days, very stormy days. So the blue color, remember, always is a reflection of the light.
Got it. Oh.
Bluer.
Yeah, it's a lot bluer.
Not necessarily.
That one's a beautiful picture.
Oh my gosh.
No necessarily. And doesn't mean that, for example, this area that is more compressed is older than this area. It's only that was losing the air bubbles inside. It's in the distance, there are more and more air bubbles inside, you can see it whiter. Why? Because the light pass pure white from one bubble to the other and goes on the other side pure white. When the light passes through this, like a glass, is decomposed in all the colors, and the only color that can go from one side to the other is the blue color. The other colors are missed. The same happens when you go into the swimming pool or the ocean. If you can look with this, you are doing a snorkeling, and you can see in the first inches everything looks with all the colors. If you are going deeper and deeper, turns bluer and bluer and bluer and bluer, because the blue color is the only one that goes up to the bottom. And as well as we can see sometimes the water of the ocean or the lake blue, and if we take a glass of water and the water is not blue, the same happens with the ice. We have a piece of ice and look transparent or white, but it's not blue. In a huge piece, when the light passes through, looks blue. This is called, so I'm going to put it.
You did hold that for a very long time.
I was going to
Yeah, we appreciate it.
Very interesting.
You'd be on land right here because it's all receded so fast.
We have to remember always that we are worried because the glaciers are receding faster, not because the glaciers are receding. Because the glaciers were receding in the last 10,000 years when the last ice age finished. So, if the glaciers were receding in the last years faster than in the last 600 years is what worries us. The same happens in other places that we are worried because it rains a lot or it's not raining at all. So it's not that we are worried because rains. We are worried because rains a lot. So that is the difference. It's the quantity. So the glaciers were receding really fast, and that is one of the problems that we were having in the last year. Yes, because it needs to survive in the water.
Don't let it die. Plus we're gonna get
I think you killed it.
Are called calving glaciers, are the glaciers in contact with water, and because are calving, so that means that the glaciers are losing ice because of mainly 3 reasons. If the glacier is not in contact with the water, it's not having a wall. The wall is because the water is eroding the bottom and the walls are falling in vertical way. Something very similar that what happens when there are cliffs in different beaches in the world. When you have the ocean going up to the cliff, you have caves under. It's dangerous because the cliffs are falling. The same is happening here with the glacier. When the glacier is not in contact with the water anymore, like you can see some parts of the glacier outside the water, you cannot have a wall. A wall is a consequence of the calvings. And we can see the end of the glaciers, so that means that the origin of the glaciers is at the top of the mountain. There is a place where the ice is compressed or the snow is compressing to form the glacial ice, so we can see the end, that is where they are calving.
My God, it's endless. Look at this. Huge. I have to turn 360 to get it.
Of the Arctic, so to be in this archipelago of Svalbard, to be in front of the biggest glacier that we can find in the archipelago is amazing. For me, that I was working with glaciers for 24 years, is amazing to be seeing the biggest glacier in here. So it's great. All this ice is calving from the glacier. We are in an amazing, beautiful day, but if we are having a windy day, then most of this ice disappears very fast.
Awesome.
Because the ice is melting faster when the water moves. That is the same that you can have with your whiskey. If you have two glasses of whiskey with the same piece of ice and you leave one on the table and you shake the other one, the ice of the glass that you are shaking is going to melt
disappear.
faster
It's
than
true.
the one that you leave on the table. And it's because of the movement of the water. So that is what melts the ice.
So we got lucky.
We are very lucky.
Yeah.
Very much so.
Wow. This is so impressive and beautiful.
Yes, they are. Yes, the glaciers are similar than the ones in Patagonia, in New Zealand, in Alaska, in Greenland. The glaciers really are divided. First of all, depending the places where you can find them. So that means you can find the polar glaciers that are close to the poles, you can find temporary glaciers. That is like Perito Moreno, where I live, because it's in Patagonia. We are not close to the South Pole, so it's temperate place. We are at the latitude of London in the Northern Hemisphere, so those are temporary glaciers. Then we are having tropical glaciers that are cold as ice, but are located in tropical latitudes of the world.
Was that like the one in New Zealand, the Fox Glacier?
The Fox Glacier is a temperate glacier, like is the ones in Patagonia, because it's a temperate place of the world.
Yeah.
In here, as I told you, are calving glaciers, because all of them are in contact with water and are calving. And many of them are valley glaciers, so are flowing by the valley, clear valley of between mountains. And the most of them, because I can see it, and it's my first time here, are compound valley glaciers. That means that are composed by other smaller glaciers. If you have the one at the front where you can see the Zodiac, you can see that there are different glaciers making it. So like in a river that you have tributary glaciers, tributary rivers joining a bigger one. Here is very similar, so you are having different smaller glaciers making a bigger wall. So that is a compound valley glacier. So we can say that it's a compound valley calving glacier in a polar area. So we have a lot of descriptions. When the glaciers are not calving, that means that are not in contact with water, are
Oh my goodness.
hanging glaciers. We call it hanging because look like that are suspended on the slope of the mountains.
This way in front.
There are only a few places in the world where the glaciers are formed
Look at that.
at the level of the sea, or in a very flat area close to the level of the sea. If not, the most of the glaciers in the world are formed at the top of the mountains where the temperature is lower than at the level of the ocean. So that means that the snow is not melting during the summertime.
It's going to.
Did they find the seal or no?
Yeah.
Yeah, it's right in front of us. We'll see it in a sec as soon as
Behind
Really?
this giant ice.
Oh my gosh. Supposedly right in front of us.
I haven't seen it.
We're gonna see it shortly.
Yeah, it's right.
You can see it?
Yeah, we'll go around the corner in a bit. I just have to get rid of ice again. Yeah.
There is a
maybe
traffic
it's the
jam
boat.
because of the ice.
So it's directly behind this ice chunk. There's a boat.
There's two boats.
There's a
Oh,
boat right up there.
By the side, it must be.
And here you can see an iceberg that look green, you can see. And the greener color
Yeah,
is
yeah, yeah.
because of the dirt. So that is what is confusing us. When it's some dirt inside and the blue color is mixed with that dirt, green.
that was pretty too. Anyway,
Yeah, so it should be right in front of, for you guys, right
you
in
can see it.
pretty much where the
brown
bow is
lump.
pointing.
He's like 12
right
o'clock.
about now.
12 o'clock.
12 o'clock.
Yeah, I don't see it from here.
It's a brown lump.
You can see it with our naked
It kind
eye.
of blends in with the two boats right in
Yeah,
front
that's
over there.
yeah.
But he's almost as big as one of the boats.
I can see it now.
Yeah. That was the one I showed you from the room.
Yeah, the lots of bearded.
Yeah.
You saw that from the boat,
Yeah.
from the cruise ship?
Yeah.
Oh my God! You must have awesome binoculars. I need to buy those.
Yeah.
Oh. I can hardly walk, see a few feet in front of me. So.
He's over here. 1 o'clock. I don't know where. See the lump on the ice?
Oh! Oh my God! I think I do.
The bearded seals, they're the biggest ones we have up here.
Wow.
2 o'clock.
They're the favorite meal of the when they get it.
Now we need to see the polar bear.
Kilometers away. I counted that one as well.
How many have you seen? How many polar bears?
I asked them that. I think it was 4 or 5.
Wow.
Those ice bubbles because it's trapped air from in parts thousands of years ago. Yeah. So they extract that air and research with those.
You're kidding me.
No, it's true.
They extract the air. How do they extract it? Oh.
Wow.
Whoa.
Oh yeah, you can see that one.
Oh my. Oh, it's right there. Oh.
Yeah.
Oh my
yeah.
gosh.
By the cave.
By the cave. Yeah, yeah, yeah. Oh my God, like thunder.
You know that those caves usually are made, but this kind of water is melting in the glacier that form like a river that we cannot see. Because, so that rivers are making like a tunnel that is going under the water, but the water running is producing these kind of tunnels that are getting bigger and bigger, and usually are more typical from the summertime. The ice is melting at the top, and the ice is melting because, for example, of the very windy days, that the ice is melting because of the wind. What happens with all the little ice that is melted at the top of the glacier is going down by the cracks and the crevasses, and finally they are making like streams or rivers inside. If it's a heat or a hot day, also it's going to melt. If it's rain, for example, all that water that is at the top of the glacier is going to down in some way and form like a river. And that river is going out at the front of the glacier, and that produces the caves that we can see are more typical from the summertime than winter time, where there is less melting of the ice.
Let's see. Oh, there he goes.
You can see this hill.
Yeah.
No, it's not that easy unless you get it with yours.
Oh, wow.
This is fun.
Yeah.
He's kind of reddish black. See the face? I don't think so.
But was when we were in the pack ice, that was like to see.
He's having a very good nap. Wow.
Quite small, so
He or she.
Oh, yes.
yeah.
Any idea if this is a male or a female? No, right?
They're quite hard to tell apart.
Yeah.
Oh, yes, you can get his face right here.
From bearded seals, no, we just have to make sure, or just in general, for all animals, the rules up here to not disturb them. So we're looking quite closely to see how it reacts. And as long as it's on the ice and not moving, we're good. But yeah, if it starts showing that it isn't a fan of us being there, then we'll retreat.
So what does your fuel filter look like? Does it look like it has a layer of water in it by any chance?
What?
No, it looks like that. Or maybe.
I'm telling you, we're going to sleep here. There is something wrong with our tender.
Mine can swim and dry.
We are taking turns.
First.
The third turn.
You're welcome. Bring the polar bear.
Wow. Wow, wow.
Oh, is he coming to our rescue? No, he's picking somebody up. No, that. No, that.
Yeah, if he's picking someone up, but we might take it if we need it. We have enough zodiacs.
Look how pretty that looks with the reflection.
He's just putting his head up now. Yeah, I think so. It's higher.
Yeah, no, it's true. The less heat they lose. That's also why they're so big and compact and round. It's the best way to have the surface ratio to. They lose from everywhere, but the more compact, the more round the animals are, the less surface they have per volume.
Like 2 miles of ice falling at the same time. No, they are going to. It's going to be falling in smaller pieces, so that is not going to.
He's picking people up. What's happening?
Uh-oh.
Seriously?
Rescue at sea.
All the rocking and rolling that we're doing. That is not cabin. That's the anchor of the other boat going down.
Half a trip.
That's enough. Discounted price. You get only half the ride.
You are filming that. You are dangerous.
I'll sell it to you later.
Under the water, so we can see how the icebergs continue.
Oh,
But it's not something that.
oh, I wish we could go close there.
His head is down. It's up again. No, it's a different.
Because here
Wow.
you can see that the wall is higher and look that bigger, but that glacier.
Yeah, see his, oh, he put his head down now.
It would be nice if he knew.
Up and down.
He's pretty big though.
And that one, I guess that is called a forever or even called 7 feet under the water. And for us it's very impressive. And sometimes you have a glacier that is having 50 feet and 50 feet under, but what we can see is what impress us. So it's not what we cannot see. So maybe that part of the glacier is almost all outside and it's not much down, and maybe that part, because the ocean is deeper, the ice continues up. So remember that the ice that is, the glaciers are not floating. The ice that floats is the pieces that are falling from it. So it's not that it's a proportion.
My God.
We are talking
How
about
gorgeous.
ice, small ones or huge ones.
Those
It's
are
between
big
10 and
whiskers.
20%, or even 30% that is outside the water when the other part is under the water. Depends of the salinity, depends of the sediments, so the things floats more in salty water than in fresh water, so that is why it's between 10 and 30. How much is 10 or 15%? 15% is like the head of the person, while the rest of the body is inside of the water. That is why sometimes if there
impressive.
are icebergs and it's a very hot day, the ice is not melting really fast because of the heat, because
blue,
the
that's-
90 or
Yeah.
80% is under the water.
Wow, that's really beautiful.
If we are going into the water and we leave our head outside, we are not going to survive only because our head is outside. The water is cold enough to freeze us. So
Now he's looking all.
Oh, you moved and I missed it. Come on, baby. Say hello or goodbye.
So beautiful. Blue. Gosh.
Oh my God, I enjoyed this so much. So beautiful here.
is a battle with this one.
And we might spend longer. She's trying.
Yeah, he's looking at us right now.
Oh my gosh.
Did you get him?
I can
He's
get it.
looking at you.
I can see what I take. I'm blind. I'm half blind.
Oh, now he's turned away.
He did.
Now he's looking again.
Oh, that's nice.
And look at it now.
in the previous trip, 1 mile away.
Okay.
For a while.
She has
You did. You did. But and with bare hands.
Yes.
We're gonna have a competition and see which guy can hold the ice longer. Let me see.
Yeah, it doesn't go so fast.
Oh, that's okay. Don't worry.
Those
I'm looking at the ice.
have bananas.
Why don't you move when I'm taping you? Where on earth does he go to the different positions?
Yeah. There, his head is up again. Yeah.
All that is all ice
Oh.
under the sediment.
Okay, we know you're real.
So what looks like dirt, there's ice in it.
It's under, yes, and we can see part of the wall.
Sitting on it.
You're getting hungry.
What you
Go
can
and
see behind the
fish.
ship, you can see the ship that look like
We want to
chocolate.
see you go
All
into
that
the
is ice.
ocean.
All that is ice. And the sediments that you can have from the glaciers depends on the
baby.
mountains that they are having around. So if it's a very hard rock, you are not going to have many sediments because the glacier needs to be very strong to break the rock and to have the sediments on it.
He's got some good shots. What is he doing now? Just the beach of it. So bored.
He looks bored. You should go for a dive. Oh. No, he was so cute. We are crunching ice.
Oh yeah, you can hear that.
Are we gonna listen to the bubbles?
Huh?
We're not gonna listen to the bubbles.
If we're gonna listen to the bubbles?
No,
Yeah, we can do that when we get in a bit thicker ice.
You got me.
Turn off the engine, have a bit of silence for a minute.
Is it gonna turn back on?
Yeah.
He's just lifting his head up. Hey, come on, baby.
Ja, ich würde jetzt hier noch mal ein bisschen näher an den Gletscher fahren und dann einmal Motor auffahren.
You think it's injured?
Also wenn
Yeah,
in
he's
der Nähe
got kind of
bleibt,
like a line goes to the back.
ja, das
Oh,
hört sich ja besser an.
I hope not.
That's a guillemot flying right there.
Yeah.
Quite
Guillemot.
cool birds.
Yeah.
Is the perspective that we have from here.
Oh, really?
Yes, it's really the perspective that we have. We can be at 300-400 meters away from the glaciers. This kind of glaciers is not allowed to get closer, and that is like 1,000 feet or almost 1,200 feet away. That is a lot, and it's because of the calvings. We have to be aware of the possible pieces of ice. The ice can calve in two ways from the area that is outside. They can go inside in this way, so the tower is going into the water, or the tower is falling like a tree. When the tower is falling like a tree, there is a very big splash, and there are pieces of ice flying away very, very far. And the ice is moving very, very fast. But also, if there are pieces of ice coming from the bottom of the ice that we cannot see because the glacier continues, that ice is coming up and we cannot see it. There is not a crack in it. They are the biggest icebergs that we can see because I'm not having the crash on the water. And once that the ice is detached from the glacier and coming up, it's moving really fast out of the glacier because of the physics. The water push it out, so we have to be always at 300-400 meters away from the glacier. And the glacier is so big that we are losing totally the idea of how big it is.
Perspective, right?
The perspective. If
Yeah.
I'm telling you how many miles,
Yeah.
how high it is, it's very difficult to figure it out because we cannot notice. We need a known thing to see it. The mountains were very impressive, but now that we can see the ship over there and you can see the mountain behind and the glacier that looked like a small glacier behind is a huge glacier. What is very interesting in that glacier is that you can see like a pyramid inside of the ice. Can you see that kind of peak that look like a cone inside of the ice? That is called Nunatak. And the Nunatak is a peak of the mountain that is surrounded by ice. That was very common in the ice age. Many of the peaks of the mountains were living outside the ice, and that is why many of the mountains are like having this cone, how you call cone shape.
Yeah.
It's because the ice was passing by the both sides and were eroded them. And when the ice begins to melt, and that look like an island, it's an Eskimo word and means like island on the ice, and the name is Nunatak. And we can see a Nunatak over there. It's that peak that is surrounded by.
So when you're talking about this glacier, how does it include these smaller glaciers over here, or is it where does it start on the left?
Here it's a huge glacier that is nourished by many different glaciers at the top. So you can see that is one single wall,
Yeah.
so nourishing by many other glaciers.
Okay.
That maybe that happens years before with more glaciers that were connected. So no worries, we can see a glacier there at the back,
Yeah.
that for me is very beautiful, that look like a single glacier, and maybe in the long time when all this bay was covered with ice, that was connected with a huge, bigger glacier in the future. If we are coming here maybe in 100 years, hopefully I will be working here with her, and we are coming in a zodiac ride, and maybe we cannot see a single very big glacier, we can see many of those hanging on the mountains. When the glaciers are receding, maybe the ones that were going together are two single glaciers that are not linked anymore.
So the zodiacs that look like they're very close to the glacier, they're really not that much closer, right?
Are not really, really close, look like.
Yeah.
We are approaching and the glacier looks almost the same.
Yeah. God, it is huge though. Look at this. Starts from here. And it goes all the way around.
It's not melting because it's cold, but we are not feeling freezing cold. So usually the ice, which is like white, like the snow, reflects the heat more than us, that we absorb the heat in a sunny day, for example. So there are many things that are quite interesting.
Yeah, the special thing about Svalbard is also that we have the Permafrost, that in the inland goes a few hundred meters deep. That's why these glaciers here move a lot less than the ones on the mainland or in other places of the world, because the glacier is cooled from the bottom.
Yeah.
That is a very interesting point, because in Patagonia the glaciers where I live are very similar visually, but are moving faster. And are moving faster because the ground is not so cold, and because the glaciers are lubricated. How? In summer, because there is water melting at the top. This water that is going to the bottom is between the glacier and the rock, and that helps to lubricate it. So when the glacier have a speed, also melts because of the pressure. So all that water at the bottom helps to the glacier to move faster during the summertime.
Yeah.
What about the friction? Increase the heat, right? It just moves now.
And it depends of the speed that the glacier is having, and that depends of how steep is the mountain where they are flowing. That is why it's very complicated to tell you how old is the glacier. This is not something that you take a piece of ice and you can make numbers and you say, I make it, like you can do with organic things, that you can know how old they are. With the ice you cannot notice how old it is. So that is why to take the bubbles of the air that was capped in the moment that the ice was made, you can maybe find particles inside of the ice that are organic particles, that is giving us the clue how old the ice is. Faster in the center than on the sides. So maybe on the sides, because it's the slow way, the ice is older. The one in the middle was reaching the front faster. So not all the front of the glacier is having the same age. Especially when the ice is coming from tributary glaciers. So it's not the same if the glacier was flowing for 60 miles from the top of the mountain, or 15 miles because it's coming from a tributary glacier from the left. The same happens in the Mississippi River. You cannot go to the end of the Mississippi River, take a glass of water and know how old the water is, because you don't know if it was coming all the way from the beginning of the river or if it's coming from one of the tributaries.
My God, look how beautiful.
Thicker here, more ice blocks.
Do you guys get any color during, whatever sunset there is?
What do we get?
Any color when the sun goes close to the horizon, you know, like I know it doesn't set. I know it doesn't set, but it goes close to the horizon, right?
Yeah, not really at the moment. It stays pretty high, so at the moment it's like the lowest is around there.
Yeah.
Like 45 degrees or something, so we don't really get a change in light. It makes it quite confusing. But in April and May, it was beautiful because we had these days-long sunsets, and that was pretty fantastic.
Oh, that's awesome! Oh, I'm gonna have to come back. April and May.
Very consistent.
Wow.
Change a lot like this.
I love sunsets.
Well,
Can
right
you
now
imagine?
it's
Yeah, like a whole day of the sunsets. Oh my God.
Colder than -2 because the
Gotta
ice
have a
doesn't
lot
freeze.
of videotapes.
So
We don't need you. This is following us. We're good. They're really good. You know, he's shadowing us, I think, in case we need to be rescued.
The biggest one just looks clear.
yeah.
Visible.
I think we're good back up. There it is.
We are crunching.
That was a big flat one.
Crunch, crunch.
Around there, it would be like, oh, that's meters again though. So times 3. we know. So this would be maybe 20 to 30 meters probably.
Wow, 30 meters. That little one. Wow.
I like it into a pool. If it's a 25-meter pool, a 50-meter pool.
Really, really lucky. You don't know that yet, but you're gonna be
Okay,
happy
this
about
is so
this.
nice. Look at that.
Yeah, we usually do.
Everything is so beautiful. It's like a work of art.
Around here always come from the further north, the Arctic. Or
Hi guys. Did you see that polar bear?
No, it's okay.
You didn't see the polar bear trying to eat the seal?
From the beginning. Yeah.
We volunteered to swim, but they're not letting us.
We should do it.
Yeah, we can get a bit closer to that iceberg and then listen to it pop.
Okay, that sounds good.
Okay, time to get off, everybody. Yeah, see the dirt in there.
Close enough.
Yeah, that's
It's
your
like
home
rock
for the
in there.
next week. We'll pick you up in 8
No,
days.
can't.
Well, if the seal can do it, we can do it.
What do you mean? Took it up the rock.
But if you're quiet now, then you can hear the popping.
Yeah, I can hear it. Beautiful.
That was calving.
Like jellyfish.
Yeah, they do look like
They look
jellyfish.
like jellyfish.
I love how many sounds you hear. Yeah.
Oh, that was so lovely.
Oh, it's quite clever.
No. That one's
Beautiful.
luminous silence.
Oh, how nice.
This kind of snap crackle pop that we're hearing, I don't remember hearing that in Antarctica.
No.
Did
No.
we miss it? Or is it-
No,
is
we
it
can
different?
hear it, but no, it depends of the place. We don't find always places with it or this ice, but it's happening. It's not happening much where I live,
Okay.
but the truth is that we are not visiting the glaciers where I live by zodiacs. So when you are in a bigger ship, you cannot hear the cracking on the bubbles, or if it's windy. But today is the perfect day to listen.
It was very special, I have to
I
say.
don't recall
Thank you.
hearing that
No.
when we were there, even on the little
No, it's
Zodiac
an,
excursion.
you need a special moment, a special day. In our last cruise, we were doing something similar to this, but was one single glacier. It was not like here that is all the bay full of glaciers, and we were passing by some ice. It was really wonderful, and when we were returning, the wind was blowing already, and the most of the ice was disappeared. So if we were arriving 2 hours later, we were not having the same experience.
Oh, wow.
Sure.
few times I did that.
It's very peaceful.
Yeah, it is. That scared me.
But they are having the same regulations.
Yeah, and it's just to check usually to make sure that everything is on board. So it's not as much that they have to improve something, it's just to make sure that it's still on board and stuff.
I can't get enough of this place. Look at that, with the light coming down.
I never been in other parts of the Antarctica environment.
So what do you think of Quark?
No, I really like Quark. I was following Quark. They go to we can see them, and it's very difficult to recognize them.
They're
But
also
here
quite aggressive.
Here there is not other choice.
What was really cool on the Amazon though is there's 2 types of freshwater dolphins.
It's time to go home.
We are giving up.
Her Hannah's tired of pumping.
That's more
Wait, if I throw
adventure.
it to you?
See, I had to eat my words. We do need you. Yeah, that's part of the adventure.
Real expedition.
Yeah. You are the hero. You're rescuing us.
We're going to be eating that exhaust, not so fun.
Yay! New experiences. That turning ice. Oh my goodness. We have calving. Wow. Seba is saying that we don't have to worry about getting dark. It never gets dark. That was a huge one.
Take this to the bar.
Our rope is okay.
We'll take it to the. It's gonna be nice and fresh.
Now he's lost his.
Have to put or eat more salt and stuff like that because the water doesn't have, or the water we melt doesn't have minerals in it.
Interesting. Seba was saying that if you melt an iceberg, it's safe to drink, but it needs to be mineralized if you're going to do it. If you're going to do it for a long term.
What's the problem? You got it on?
Yeah,
He's trying to get rid of us.
Oh, no. You are not a Boy Scout, huh?
That's a good job, though. I like that.
Just tie more of them.
Yeah.
The bowling.
Yes, exactly. He's giving us a chance, he says, to take a nice picture of the ship.
Oh, okay.
Crunch. Yes, we're explorers, adventurers. Look at the tender going up.
He's just taking us for a ride.
Yeah.
Oh, yeah.
Hey, little show-offs.
They're impatient. We have to go to the restroom.
Maybe. We'll give them that excuse. They need to go to the bathroom. That's it? No more icebergs? Oh, find the big one. Yay. Can we bump the boat? All right. Bumper cars. Hi, Ocean Diamond.
the boat.
That was so nice. Yeah. Only special people can touch ocean time.
Me on the bar.
Yeah. Thank you very much. Yay. Our hero. And I think this is the boat with the scouts. We still had scouts, I think, for polar bears. They all carry rifles to protect us. I have to say they did a really good job with the experimental Zodiac. That was so much fun. They are prepared for everything. Yeah, they all have their rifles. I want to see how easy they get out. Look at that, 1, 2, 3. We do it sideways, they do it head on. Two rifles. After all that. He's got energy to dance.
Lemon ginger tea.
Hot chocolate and dancing. That's fun. And we have the scanners. He's starting a whole thing. Oh my God, look at the moon.